Right. So the welcome Dr. Veera Prakash online organic chemistry for NEET students and IITG or advanced examination purpose. I am making these videos, and today I am so one of the important video is that the predicting the products, the substitution versus elimination reactions. So in this area, so because it is a commonly the students will do the mistakes to identify whether the reaction is, whether it is a substitution reaction or elimination reaction. So generally it's a very trick to identify. So here I am going to give some clarification and some tricks easily to identify whether the reaction is undergoing substitution, nucleophilic reaction or elimination reactions. So we know that the substitution or elimination reactions are two types, right? One is the SN1 reaction and another one is SN2 reaction. What about SN1? It is a unimolecular substitution nucleophilic reaction. Is nothing but the rate of reaction. The rate of substitution reaction is depends on the concentration of alkyl halides alone, not on incoming nucleophile. So even SN1 reaction can proceed via even in presence of weak nucleophile also SN1 reaction is possible, whereas SN2 reaction is not like that. Very strong nucleophile is required. So in SN2 reaction there are two important factors. One is the substrate and also the incoming nucleophile are influencing the rate of reaction. So in bimolecular, so that's why substitution nucleophilic reaction, SN2 reaction is a bimolecular substitution nucleophilic reaction. So why it is a bimolecular? Because the nucleophilic substitution reaction is depends on the concentration of the incoming nucleophile as well as the substrate. So primary and secondary alkyl halides undergoes SN2 reaction and SN1. So tertiary alkyl halides and alkyl, right, allylic and benzylic position. So wherever the more stable carbocation is involved in that, so there is a SN1 reaction. And similarly elimination reaction, beta elimination reaction. So in beta elimination reaction, alkyl halides in presence of a strong base. Once it is a strong base, so it is a E2 mechanism. The nucleophile is very strong so that it subtract the proton. So elimination reaction E2 is a predominant, and simultaneously once in E1 mechanism, so it will follow through the carbocation stability. Where the more stable carbocation intermediate is formed, then elimination reaction is taking place. So that is the E2 mechanism. So in this, so there is a predicting, how to predict the products, the reaction is proceed through a substitution or elimination reaction. So substitution and elimination reactions are very of a competition. So whether the elimination or substitution, so there is a competition will be there with each other. So in order to predict the product of a reaction, it is necessary to determine so which mechanism likely to occur. So it's a very important to identify which reaction mechanism it follows. So here very simple example is there, and for example tertiary butyl iodide is there, and here because sodium methoxide is a strong base and elimination reaction, so it gives the E2 product is isobutene. The isobutene is the product, and similarly 3-methyl butane, 3-methyl-2-bromobutane under sodium hydroxide base. So it is the two reactions, three products can be recognized. One is the major product and minor product, and another one is the substitution product. So the question is that the major product is alkene and more substituted product, it is the stage of product, and less substituted product is the minor product, that is Hoffman product. And also even because it is a secondary alkyl halide, so it undergoes a substitution reaction, also possibilities is there. So in this, and another important, for example, right, for example even alkyl halides, for example you can see the conceptual checkpoint, for example solvolysis. We know that solvent like ethyl alcohol or methyl alcohol or water medium. So for example alkyl halides reaction with solvents like methyl alcohol or ethyl alcohol or ethylamine, the reaction may taking place substitution reaction, also elimination reaction. So the conditions are very important. So students can be carefully notice that the reactivity of, here you can see that the phenyl ring is there, and here the tertiary, here methyl is there and methyl is there, so here bromine. So now this is the a tertiary, so tertiary position is there, so which is more reactive. So in this example, so because of once it will form a carbocation, so there is a both hyperconjugation, positive hyperconjugation as well as a resonance structure is possible, so that is more reactive than without aromatic compound. So this is the more reactive. So another second example you can see, so it is a primary, once it will so it will form a primary carbocation, and this migration of this one. So even though it is formed a tertiary carbocation, but in this one you can see that because there is a resonance is there. So once this is the allylic. So allylic is the more reactive than a normal primary alkyl halide. So that is the reactivity of. So another example you can see, both are allyl chlorides and allyl bromide, but in this example the chlorine is less reactive than bromine, because we know that the iodine, the reactivity is that the leaving group is that I minus and Br minus and Cl minus followed by F minus, so that the easily it can livable, so that the reactivity is yes. So this is the more reactive, bromine is more reactive. So another one, the trick is that, so draw the expected products of the following solvolysis product. So for example you can see in this example solvolysis, so very sometimes difficult to predict. So solvolysis product, for example you can see now it is a tertiary halide, and what is IUPAC name of this one is that so now 1,1 dimethyl 1,1 dimethyl benzyl bromide reaction with methyl alcohol in terms of heating condition. So under heating condition, so both actually this under solvolysis, because we are not using any base, so that both SN1 reaction as well as E1 reaction both are possible. So bromine is replaced with OCH3. So OCH3 is the product, and another, for example so here also another example you can see that 1 2 3 4 5 and 3 bromo 3 methyl pentane under H2O as a solvent and heating, so it undergoes both the products. So alcohol, bromine is replaced with substitution product, and another one eliminated, more substituted product. So there is a two products, SN1 reaction is possible and E1 product also possible, but under thermal condition elimination product lightly, for example this is 60% product and substitution product is 50, means 40%, like that, means slightly variation will be there. So solvolysis reactions here you can see, so for example 2 bromo 2 methyl butane reaction with ethyl alcohol under thermal condition, so it undergoes a substitution reaction. Also there is a possibility for elimination reaction also, because almost equal product can be distributed. So here, so for example this is also, so 1 methyl 1 chlorocyclopentane and H2O thermal heat, there is a chlorine, because very important chlorine, and once, so there is no doubt bromine and iodine are very good living group, whereas chlorine is a weak living group, so that the substitution product it may be predominate. So that's why alcohol. So one methyl, one hydroxy cyclopentane is the product, and you can see here even now the two phenyl rings are there, and bromine is there in methanol, and water is the nucleophile, so that there is a yes, Br is replaced with OCH3, and also alcohols also it gives the some product because water also as a nucleophile. So another one, so you can see here this is the chlorine is there, and so in this tertiary, this is also tertiary alkyl halide reaction with methyl alcohol, so that chlorine is replaced with OCH3. So this is also good example, and in this case, for example, tertiary butyl bromide, in presence of a strong base sodium methoxide, absolutely no doubt it undergoes elimination product. So what I would like to say is that the prediction of substitution or elimination reaction is depends on, one is the criteria is solvent, which solvent is polar protic solvent or polar aprotic solvent, and if no doubt polar protic solvent SN1 reaction is predominant. What are the polar protic solvent? Methyl alcohol, ethyl alcohol, 1-propanol, water medium. So this and all polar acetic acid, polar protic solvent, and polar aprotic solvents. Polar aprotic solvent predominate SN2 reaction like DMSO, dimethyl sulfoxide, DMF, dimethyl formamide, dimethyl acetamide, DMAC, and so for example tetrahydrofuran, THF. So this and all, some dioxane, 1,3 dioxane also very good example for SN2 reaction. So one is the important criteria is the solvent effect, and another one, so very interesting example I would like to explain is that, yes, so the predicting the products whether the substitution or elimination. So now the effect of base, so very important. We know that a base as well as same compound can exhibit the both dual nature. One is a base character and another one is nucleophilic character. So here I am giving a very nice explanation. So one is this, what are the three different categories are there, or four different categories are there. One is the, so classification one, strong bases and weak nucleophile. For example, sodium hydride, DBN and DBU. So this and all you can see what are sodium hydride and DBN and DBU. These and all very strong bases, because you know that this and all very strong bases but weak nucleophilic character. So no doubt once we are using a potassium tertiary butoxide or a triethyl, yes, tertiary ethyl potassium butoxide, no, that one too, yes, so tertiary butoxide. So once we are using bulky base, no doubt, because you can see this is the triethyl and this is the tertiary, so this is also very bulky base and potassium tertiary butoxide, no doubt, and this is the 1,5 diazo bicyclone 4,3,0 and 5-ene, and also this is very, because once it will form a hydride here, so this is the because of resonance stabilization, these three are very strong base. Sodium amide NaNH2 similarly. So these are very strong base. So just come to here, and second classification is that strong base are also, it can act as a strong nucleophilic nature. For example, hydroxide and sodium methoxide or sodium ethoxide, these three anions are very good strong base, and also it can act as a strong nucleophilic nature. And another third category, some of the nucleophiles are act as a weak base, but they are very strong nucleophilic nature. What are that? So I minus, iodide, bromide, chloride, okay, RS minus, thiolate and thiol, HS minus and RSH thiol hydrogen sulfide, you can see sulfur based anions and neutral compounds also, they are very good nucleophiles, but they are very weak base. This is the third category. And fourth category, weak base and weak nucleophile and neutral molecules like H2O, ethyl alcohol and methanol and ammonia. So these and all, yeah, ammonia is a very base, strong base, right? So now H2O, ethyl alcohol and methyl alcohol and all weak base, and also they are weak nucleophilic nature. So what is this? Is the table is very important for students. So let's say it is a alkyl halide. So now y-axis like that, this is the table: primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. So once we are using a strong base, and if it is a it is anion is strong base and weak nucleophile, so E2 reaction, primary, secondary, tertiary alkyl halides undergoes E2 elimination product. Whereas second case too, if it is a strong base and also it is a strong nucleophilic nature like OH minus, methoxide anion or ethoxide anion, so if it is a primary, then SN2 reaction is predominant, and if it is a, yes, E2 is minor product, and secondary E2 is predominant product, SN2 reaction is minor product. If it is a tertiary, so elimination, E2 product is the major, that means olefins are the products. So in case 3, if it is a weak base but it is a strong nucleophilic nature, what are that one? For example, I minus, Br minus, Cl minus, Rs minus, Hs minus and thiol, hydrogen sulfide, these and all weak base but they are very strong nucleophile. So primary, if we use this type of nucleophiles, and now the primary alkyl halides undergo SN2 reaction, secondary alkyl halide undergo SN2 reaction, tertiary alkyl halides undergoes SN1 reaction. So then last category is that the weak base and weak nucleophile. So primary alkyl halide, no substitution reaction, no elimination reaction. Secondary alkyl halides, no substitution, no elimination reaction, only except if it is a tertiary, then only. So that's why you can see that 50% SN1 and 50% E1. So there is a 2 possibilities of reactions. So that's why tertiary alkyl halides under the neutral medium, neutral nucleophiles undergoes SN1 as well as E1 product. Come to the examples. So now example, for example, primary substrate. So for example, 1, 2, 3, 4. So 1 bromobutane reaction with sodium hydroxide, it gives the 2 products. One is the elimination product, another one is the substituted product. So 1 butane. So now 1 butane is eliminated, is the 1 butane is a minor product. So why it is a minor? Because sodium hydroxide is a very strong nucleophile, and also, but you can see, look at the table, because it is a primary, so that it undergoes SN2 reaction is majority, so that major is SN2 and minor is E2 reaction. So then if it is a substrate is secondary alkyl halide, if substrate is secondary alkyl halide and reaction with strong nucleophile, sodium hydroxide can act as a strong nucleophile as well as strong base, it gives the alkene. So olefins are the major product and substitution product is the minor product. If it is a substrate is a tertiary alkyl halide, and no doubt elimination reaction, only elimination. Please notice that, very very important. If the substrate is a tertiary alkyl halide, under the basic condition it leads to the E1 product, elimination product. So another example, you can see that. So now so 1 bromobutane, now the base is potassium tertiary butoxide. So what is the characteristics of potassium tertiary butoxide? Is a bulky base. So you can see that the structure, you can see. So now methyl groups is there, and it is a very bulky group, so it can act as a very weak nucleophile, but it is a very strong base, so it gives that even though it is a primary alkyl bromide, but it gives the major product is that elimination product 1 butene. So less Hoffman product, less substituted olefin. So the minor product also appears, but minor, it is SN2 reaction. Similarly, for example, Yeah, 2 bromo 2 comma 3 dimethyl butane, so H2O under thermal. So please remember that because H2O is a weak nucleophile, also it is a weak base. So under thermal condition 50%. So there is a possibility of alkene as well as alcohols also there is a possibility. So both products can be expected, but major because we are heating the sample, so that elimination product is a majority. For example, 70%, 30% alcohol also expected. So whereas for example this one you can see that this is the 1 2 3, so 1 2 3, yes, so yes, 1 2 3 4 5, yes, 2 chloropentane reaction with now sodium methoxide is classified as a very strong nucleophile as well as strong base. So ethyl alcohol is the medium. Ethyl alcohol act as a solvent. So now no doubt the elimination product are the major. So that's why you can see that elimination product, so the major product is elimination product and minor is the alcohol. So that is the important. So by using of a strong base, elimination product is no doubt, and if it is a, so that is the factor influence of nucleophilic nature. And you can see another example. Yes, so you can see that same, yes, pentane reaction with sodium methoxide, and so there you can expect that there is a three products. So one is the SN2 product and E2 product. So and you can see that because the major product is olefin. So why? Because there is because of elimination is a major product because of strong base and strong nucleophile. So that is the SN2 reaction. SN2 reaction is favorable. No, sorry, not SN2. E2 reaction is favorable. So then couple of examples based on this concept we can look at. So practice the skill and apply the skill. That is the question. So identify the major and minor products. For example, you can see that. So now 1 2 3 4 5. So yes, 2-bromopentane reaction with sodium chloride in place of a DMSO. Now DMSO is a non-polar solvent, so SN2 reaction is favorable, so that now Cl minus is substitution product. So in place of bromine, chlorine is coming, right? Another one, this reaction is called Franklin substitution reaction. Now this one, another example, for example 1 2 3 4 5, 2-methyl 2-bromopentane reaction with sodium hydroxide. Now sodium hydroxide can act as a strong base, also strong nucleophile, but under tertiary alkyl halide, so elimination product is the major product. Elimination product is the, so what is the name of this one? 1 2 3 4 5. So 2-methyl 2-pentene. 2-methyl 2-pentene is a major product, and also the substitution product also minor product, and even Hoffman product also the minor product. And even in place of now, for example, so 2-cyclohexyl 2-iodopropane, 2-cyclohexyl iodopropane we are taking. Now potassium tertiary butoxide is a very strong base but weak nucleophile. So that's why absolutely it undergoes E1 mechanism, because very strong nucleophile and very strong base but weak nucleophile, so Hoffman product. So that's why here I written wrong. So the Hoffman product, because it is the like that. So Hoffman product, so that's why Hoffman product is the major product. And similarly in presence of now DBN also very a strong base weak nucleophile, and Hoffman product less substituted product. For example, you can say IUPAC name 1 2 3. So 2-phenyl 1-propene is the major product. And so even iodine is there in place of a strong base, so elimination product is a major. And even sodium thiol Na plus SH minus, because SH minus is a strong nucleophile but weak base, so SN2 reaction. So SN2 reaction, that's why the iodine is replaced with SH. And another example, so now you can see 2-cyclohexyl and otherwise 1-ethyl bromide cyclohexane So you can see this is the primary alkyl halide reaction with sodium hydroxide. So now sodium hydroxide, even though but Br is a very good living group, so there is a by using of solvent, for example we are using aqueous solvent, so it undergoes elimination reaction. So under thermal condition, once we are using heating means it is a elimination product, so that's why it gives the cyclohexyl ethylene cyclohexene. So cyclohexyl ethylene is the product. So very important observation is that once the under heating condition, elimination reaction is predominant. So that is the very important. And another one you can see here, and even here bromine is there and sodium hydroxide in dilute sodium hydroxide, but no, there is not cold condition. For example, it is a cold medium, so major is the alcohol substitution product. And similarly, so now sodium ethoxide is there, very strong base, so that elimination product is the major product. So tertiary, because iodine is a very good living group, even ethanol medium and under thermal condition while heating, so major olefins are the major product. Even alcohols also, methoxides also, ethoxide, for example, so this OC2H5, this product also will be there, but it is a less product. So if it is a secondary, you can see now this is the secondary alkyl halide, so very strong base sodium methoxide in methyl alcohol as a medium, so E2 product is expected, so trans is the major product. And even in the case of, for example, cyclic ring system, for example, this is the 2-methyl 1-bromocyclohexane under sodium ethoxide, sodium hydroxide strong base, so the product is that so 1-methyl cyclohexane, so E2 product. E2 is why, because it is a strong base. So the question is that very important in this one. For example, the question is that the molecular formula is C3H7Cl under sodium methoxide, what are the products? So now, so C3H7Cl, the positional isomers or constitutional isomers like 1-chloropropane or 2-chloropropane, two possibilities are there. So if it is there, SN2 reaction, primary alkyl halide, so undergoes, there is a methoxypropane because SN2 reaction, whereas the 2-chloro, so no substitution reaction, secondary halides in presence of a strong base or strong nucleophile undergoes E2 product, elimination product. So that is the very important. And thank you.